Good afternoon, everybody. My name is Javier Martin, and I would like to go over the two features that I have created for my P&P4 class at Full Sail University. We are in a 14-person group project, and we are starting to create Excitebike from scratch. So I took on two features, the acceleration and deceleration of the bike, as well as the temp gauge functionality. And the first step that I did for the acceleration and deceleration feature is actually give our group access to Perforce. So I got in touch with the professors here at Full Sail, and I got everybody's email, and I emailed the professor and was given access to this folder right here so that we could all create our individual projects in Perforce and share our content with each other. Once that was created, I went ahead and actually examined the functionality of Excitebike through my NES Classic, as well as by using this YouTube video, which was in HD and was really helpful in seeing how all the functionality worked. I also made sure to reference that inside the script. Once I had a general sense of how it worked, I went ahead and determined which was the appropriate way to actually move a player forward. This was my first 2D project, so after looking at Unity answers, I decided to use rigid body 2D and velocity. And in order to do that, I had to create a visual representation. And this is the scene I created. I just did a rectangle and a sphere, and was able to use that to properly test it. And the most important thing out of this whole script was this float value that I created. This float value here in the script was basically moves the player forward. And once I had that float value, I determined that I would need also the player controller, which wasn't available at the time. So I created a get key input for the player. And those get keys were going to be X and Z. X being the turbo, meaning that the float value would reach all the way up to 10. And Z being the acceleration button, which would allow the player to go up to 6. Now, once I knew that and I examined the gameplay, I realized that if both buttons were being pressed at the same time, Z would take over, which is the slowest of the two speeds. So that would just, once I determined all the conditions, I went ahead and set up all the conditions in this script in the change speed function, I'm sorry. All the other booleans you see on this script are external, are used for external references, I should say, so that other scripts can call it, and I'll go into that later on. So yeah, as I scroll down through the script, you'll see that, let me just go over one. If I press X, which would be the turbo button, here I'm increasing this float value by 0.05, and this is where the magic happens. This is where the rigid body moves forward, vector 2 dot right, times this changing speed, which is actually increasing. And I set the condition that if it goes over 10F, make sure it stays at 10F to set its max value up. And another one would be if none of the buttons are being pressed, go ahead and decrease. If Z is being pressed and it's between these two values, go ahead and decrease it, because that would mean that you were pressing X and now are pressing Z, which is the lower speed. And lastly, if you are from 0 to 6, go ahead and increase it if you're pressing Z. And again, if you're not pressing any buttons, decrease the speed. It's a very simple script, and it works. The last portion of the script was, again, for these public booleans that I created. And let me just show you the functionality and I'll go ahead and move on to the temp gauge script. So as you can see, I'm pressing X right now. I'm reaching the max speed, and I go into the overheat function. It is still a little bit buggy, but visually it does occur, which is the intention. I will make sure to fix that bug at a later time. And now, lastly, I would like to say that I created a documentation for this particular feature, and that was right here. And I just go over everything we just discussed in a document that can be found on the Trello card for this feature. moving on to temp gauge. The temp gauge is another float value that is tied in to get input. So let me just go over it here. All these all these booleans that were created for references were for the temp gauge and for the overheat visual. So the temp gauge happens by calling the other script and by creating another float called current temp, and that float is going to be manipulating the image of the temp bar, which is that red sprite that you see right there. And it's basically the same function. If X is being pressed, go ahead and increase the temp gauge. I created a minimum for it, which is 0.25. Here's where I said if both are being pressed, on the other script, I'm sorry, is when I said that if both are being pressed, the slower speed takes over, which is right here. So if both are being pressed, Z takes over. That took care of a bug that I was having earlier in the project. And this script is, again, self-explanatory. It's basically the same principle as acceleration and deceleration, but now we're manipulating the fill amount of the temp bar. So, for instance, let's go over this one right here. So if that public boolean from the other script, if Z is being pressed and X is not, that's the slower of the two speeds, and overheat is false, go ahead and if the current temp is higher than 0.25 but lower than 0.26, increment it until it reaches 0.6, which is the max allowed for the temp bar. The most important feature that I like to go into is the overheat. So I wanted to penalize the player, just like Excitebike did, for reaching the maximum on the temp bar. And this is what happens. I created an E enumerator and an I enumerator, I'm sorry. And I just went ahead and said, created a float value called time. And then once it reached 1 over here, it called it, and it said that it was going to be 5 seconds right here. And this function would happen and set overheat to true. Again, this is if the current temp reaches 1. It sets it to true, and I created another script for the visual, which again is the buggy part, but I will go ahead and correct that. And this is overheat. Basically what it does, it's a very simple script that calls that other boolean called overheat that I just showed you and says if on update overheat is true, start this coroutine that will enable and disable the temp bar and also erase the text and put it back on. This is the text right here. This is where it erases it, and this is where it puts the overheat text back on. Now it's important to point out that the background that is currently green will vary, so I created different textures depending on the level you're on, and I went ahead and put them under the art asset as well. And so let me just show you the functionality of the temp gauge and also the documentation. So again, you did see it before, but let me go into it in further detail. When you press X and it reaches the top or the highest value on the temp, it will flash, it will say you overheated, and then it will say for you to go and reset so you can go. Now if I keep X pressed, and I'm still pressing X, I'm not moving. I still cannot move until those 5 seconds are done. Again, it's that text is still buggy, but then I can move again. So it does work, and let me go into the documentation really quick. In the documentation, I pointed out all the different instances for the temp bar on what its minimum is, what its maximum for the Z is, what its max for the X is, and how it resets to 0.25, and all the conditions that were met. I really hope you enjoyed the video, and have a wonderful day. Thank you very much.